The following example is a halogenation reaction with propane. This is going to be a chlorination, which means we're going to be adding chlorine, or Cl2. The previous example that you may have watched of the halogenation of an alkane was done with a structural formula type molecule. And so if we draw the structural formula for propane, we're going to have 3 carbon atoms, and then all of the rest of the bonds around those carbon atoms should be filled in with hydrogens in this structural formula example. So what you can see is that the molecular formula for propane is C3H8. We can see that by counting our 3 carbon atoms and our 8 hydrogen atoms, or since we have an alkane, we can say, okay, it is CnH2n plus 2. So our N is 3, and our 2n plus 2 is 2 times 3 plus 2, which is 8. So C3H8. Now, as I draw the example of the reaction, I'm going to draw the bond line notation for propane, and I'm going to do the reaction that way. So I'm going to start by drawing my propane molecule. So I have 1, 2, 3 carbon atoms. I'm going to go ahead and I'm going to number those, just so you know that they're there. This carbon, of course, has 3 hydrogens around it. This has 2, and this one has 3. We're going to add chlorine, and we're going to do so in the presence of heat and light. The resulting molecule is going to be that chlorine is going to break apart, and it's going to replace one of these hydrogens. It could be this hydrogen, or it could be any one of the 8 hydrogens. So what we're going to get is a singly substituted alkane. And in this case, I'm going to put the chlorine right on that carbon number 2. In addition, the other product that we get is HCl. The name of this molecule is going to be 2-chloropropane. Now, we could also have the chlorine add to either this carbon atom. So let's draw that possible product. It's an either-or type of thing. So I'm going to put or. We could get chlorine, and it's going to be bonded to carbon number 1. So this is carbon number 1, carbon number 2, carbon number 3. And then we also would get our molecule of HCl. The name of this molecule would be 1-chloropropane. Now the other option would be for the chlorine to add to carbon number 3 right here. So I'm going to draw that molecule. I'm going to draw it over here. And in this case, this was carbon number 1, this was carbon number 2, and this was carbon number 3. But since chlorine is now right here, we have to number this such that the carbon with the branch has the lowest number. So this will be carbon number 1, this will be carbon number 2, and this will be carbon number 3. And therefore, the name of this molecule is also 1-chloropropane. Now, we can take our 2-chloropropane or our 1-chloropropane, and we can do this reaction again. So I'm actually going to draw the reaction of 2-chloropropane with another molecule of chlorine right here. So we're going to add Cl2 again in the presence of heat and light. All right. And now another atom of chlorine can add to anywhere on this, any one of these carbon atoms. All right. And so I'm going to draw the possibilities. It could add to carbon, well, let's go ahead and number these, 1, 2, 3. It could add to carbon number 1. So there's my chlorine bonded to carbon number 1. The chlorine on carbon number 2 is still there, and we would make another molecule of HCl. Now, since this has 2 chlorine atoms on it, we would now call this 1,2-dichloro propane. The other option, well, actually, we could add it to number 3, or what was carbon number 3, but then we would want our numbering to be the lowest, so it would be the same molecule again. The other option would be for it to add to carbon number 2, actually, the carbon number 2 right there. So what we could have is this molecule right here. Here's our original chlorine, and here is our new chlorine. And we would make HCl. Okay. And so the name of this molecule would be 2,2-dichloro propane. Okay. Sorry that got a little crowded there. So that's the halogenation of propane, and the reaction is drawn using the bond line notation.